chat. I have an idea.
What?
Let's go to space.
What? Wait, why don't we just go to a black hole then?
Yeah, really, why not?
Cause it's never been done before?
So let's be the first people in history to do it then.
Bro, speaking of, I got really good connections at Mirzaku University.
Oh yeah, I heard their spaceship is really fire too.
Bro, have you seen the exterior?
Interior.
The outside.
Fire.
The food.
Propulsion.
Everything is nice. Yeah, shit, the spaceship's gonna be fire. The spaceship's so cool, bro.
Wait! I have an idea. Yo, wait! I wanted to go to a black hole, right? I saw on NASA, like on TikTok, that there's a new black hole. It's called Gaia. It's 1,560 light years away.
We are here. What about this distance?
Okay, let's calculate. Let's calculate.
Yeah, let's actually calculate it. Let's
Okay.
see the fastest NASA probe ever built.
Okay. 430 miles per hour or 692,000 kilometers per hour. So 692,000 kilometers per hour. Okay.
So 1 light year is approximately 9.46 times 10 to the 12 kilometers. That's a lot.
Yeah.
And with this distance, we're gonna have a total distance of approximately 1.476 times 10 to the 16 kilometers.
Damn.
Doing a little bit of math, we know that time is equal to distance over velocity, leaving us with a total time of, unfortunately, 2.4 million years. Man, this is hopeless.
What if we had a wormhole?
Wait, what's a wormhole?
To understand wormholes, you first need to understand what dimensions are. Here we go. This is 1D.
Okay.
If I turn this into a rectangle, this is 2D. If I do this, this is now 3D, right? So the concept of a 4D is gonna look like this. And like this.
Okay, but what is that fourth D? What is that fourth dimension?
The fourth dimension is what we can't tell because we are 3D beings. So we are in a 3D world, so we cannot really understand the fourth dimension yet. So, and then this is a wormhole. This is a real interpretation of this, which is known as the Tesseract.
So, okay, this wormhole is in four dimensions, right?
Exactly.
Okay.
So a wormhole is basically a distortion of space, a sort of tube which connects two slices of the universe. It is very difficult to draw because the surface, these two surfaces happen to be 3D, which can allow ships and even light to pass through it. And so we can receive an image from here. If this is my eye, I could see what's on this side.
Okay, but how does this help us with our distance problem?
Okay, so now it makes a lot more sense. A wormhole is basically like a tunnel that helps us get from point A all the way down here from point B. And in this three-dimensional plane, instead of traveling for millions and millions of years,
From here to here, right?
yeah, you could basically take the paper, fold it in half, and rip straight through time. Okay, so let's say we made it past the wormhole. What then?
Okay. Black holes. What do we know? Okay, right here. This is a black hole that we want to go to. Gaia. And this is us right here.
Okay, but what is this stuff?
This is an accretion disk. It's made up of gas and plasma that's spiraling around this event horizon at nearly the speed of light.
Okay, but why does it glow? Where's that light coming from?
It's spinning so fast that it's friction that causes that deep glow.
Okay, but does it actually emit light?
No, in fact, it sucks in everything in its path, everything around it, and nothing can escape it. Not even light.
Not even light? Okay, so if we were to land on a planet orbiting close to a black hole just to gather some data, something strange would happen.
Wait, what's gonna happen?
We might spend only a few hours on the surface, but when we return to our ship or check in with someone further away, decades could have passed. Theoretically, it's possible one of us would have aged just hours, while another has waited 20 years. This happens because of gravitational time dilation.
You mean Einstein's theory?
Yeah, according to Einstein's general theory of relativity, time passes more slowly the closer you are to a massive object. A black hole's gravity is so intense, it warps not just space, but time itself. So near the black hole, your clock ticks slower relative to someone further away.
Okay, but there's no way that's real. Has it been tested yet?
It's not just a theory actually, we've measured this. GPS satellites orbiting above the Earth experience weaker gravity than we do on the ground. Their clocks tick slightly faster by just microseconds, but we have to correct for that or GPS would stop working accurately.
But what would happen with the black hole?
Near a black hole, this effect becomes extreme. The closer you are to the event horizon, the stronger the gravity and the slower time moves for you. From your perspective, everything feels normal, but for anyone watching from a distance, you're moving in slow motion. So if we landed on a planet close to a black hole, time would stretch. What feels like an hour for us could be years elsewhere. It's not science fiction, it's a real, measurable consequence of how gravity bends the fabric of space-time.
So is any of this even possible?
I mean, we have Mirzaku's spaceship.
And we already know all about the wormholes.
And you understand the fourth dimension and black holes.
We also know about the time dilations around the black holes too.
I think we're ready, guys.
Okay, one round trip, no mistakes. To the black hole, we get our data, and we get out. This is the journey of our lives. On three. One, two, three, lines.
Bloopers are like.
Oh, it's on?
That's why, yeah.
Yo, what's up guys? It's Ash Josh. It's your boy.
What'd you do?
Why so laggy?
Yo, chat. I have an idea.
Why don't we just go to a black hole?
Yeah, why not?
Wait, right here. You want it?
Gaia. Something has to discover this recently, that's all we use.
Yeah, and that's how they do in Interstellar.
Okay, so let's see.
Why don't we?
I heard they have a really fire spaceship.
Dude, their spaceship is so nice. Have you seen the interior?
Oh no, but I really want to.
Dude, we should actually go there sometime. You know, speaking of, it's a good time right now.
For real, let's do it then.
Let's actually go to the Mirzaku University.
Yeah, right now.
Let's actually go. That's the best plan ever.
Yeah. Mason, go faster! Go faster!
Don't you.
First law.
I have no clue what Newton's
What's
first
Newton's
law.
second law?
I have no idea.
Newton's third law.
If we idea.
Oh man, this is hopeless, bro.
What if you had a wormhole?
Wait, oh, I just pointed at me. This is a BTS. Trying to figure out how to use this. This is ChatGPT. This is our, how do we like verify this result? Can give us some marks, please. I'm on the D12. Okay, I use the D12. Yeah. Thank you to Mason for helping us out. Yeah, he's just doing nothing, absolutely nothing. Make sure he gets a fail.
Yeah, 8.4 million